This is our next video after defining what qubit is, and now I will tell you why we are using qubits and why not other systems in a physical world, and why are we actually giving more importance to this kind of system rather than using the qubit or rather than using the other systems we have here. So let me explain you what we actually do when we have a multi-qubit system and what kind of complexity we are going to get in operations and what kind of problems we face when we have harmonic oscillators with infinite amount of energy levels, or a harmonic oscillator with energy level which is equal to ionization level. Or ionization level is something which you might have studied in physics or chemistry. It's all about atom and its shell and the maximum level of energy level where the electron gets knocked out of its environment. We will discuss it later. So this is a multi-qubit system. Like, consider that you have different qubits in a form, and then you have an n-qubit third system. So you have one in excited state, one in ground state, and then in uncertain state. It doesn't matter right now. So how many kind of operations you have to go through? Like how many kind of system you have right now? Actually, you have 2 power n, and the reason is that for every qubit you have 2 states, either state 0 or either 1. So it actually comes along 2 power n, but it doesn't matter because it already exists in only one from both of them. And when you have to go from this to this, you actually move it in a linear path. So you actually have to perform n operations to get from this to this in our 2 power n system. This is what actually qubits helps us in a system where you have improved our two energy level system. But right now we have another system which is also considered very promising, but it has a very huge flaw, and this is a harmonic oscillator. So consider that you have a hydrogen atom and it has different kind of energy levels to go from for electron to go from ground to excited state, or to move from to leave its substrate, whatever you have an energy level at the end. So like you can name anything. Like right now these are very subtle names, and it doesn't really matter. I named it 0001, 0000, or 1111. So it doesn't matter. Just consider that these are different kind of energy levels which an electron, which an qubit, or which a system has to go through and perform to get the computation at the highest level, to get the idea, the main crux of the computation result. So when you go from this part, you actually have to move from this part. But when you have to move from this part to this part, you have to pass this one as well and this one as well in form of energy level form. So you have to like put multiple efforts at the same time. So when you go there, you have to put efforts from there, and there. So